Hey, this demo has been presented by Philip Brownlow and Tricia Cahill. We are ex-PSD cloud native engineers within Intel, based in Shannon, Ireland. The Power Manager is a Kubernetes operator developed on the Operator SDK model. Intel SST is a powerful collection of features that offer granular control over CPU performance and power consumption on a per-core basis. However, as workload orchestration, Kubernetes is intentionally designed to provide a layer of abstraction between the workload and such hardware capabilities. This presents a challenge to Kubernetes users running performance-critical workloads with specific requirements that are dependent on hardware capabilities. The Power Manager bridges the gap between container orchestration layers and hardware features enablement. Specifically, Intel SST by allowing the user to tune the frequency and set the priority level of the cores chosen by the Kubernetes native CPU manager. A use case example of this is to pre-schedule nodes to move to performance profile during peak times to minimize spin up, and at time not during peak to move to power saving profile. The manager consists of two main components: the overarching manager, which is deployed anywhere on the cluster, and the power node agent, which is deployed on each node to require power management capabilities. The overarching operator is responsible for configuration and deployment of the power node agent, while the power node agent is responsible for tuning of the cores as required by the user.
First, we will deploy the overarching manager, which will wait for the power config to be created by the user. A power config consists of the labels that indicate to the manager which nodes to deploy the power node agent, along with the list of power profiles to be available in the cluster. The list of power profiles include performance, balance power, and power. For this demo, we will only be requesting the performance profile. So if we just apply that config. Once the config is deployed, the manager will create an instance of the power node agent on each node that satisfies the labels. It will also create the profiles, so we can see down here and up here. The power node agent will also create the corresponding workload for the given node that the power node is running on. To show the manager's functionality, we will show you the minimum and maximum frequencies of a core before and after the profile is applied. So here we will see the maximum frequency of CPU1, which is 3000 Hertz, and the minimum value is 28. Now we will apply a shared power profile and shared power workload to the node, which will lower the frequencies of the cores in the Kubernetes shared pool. Apply the shared profile first, and we'll see it being created over here. The power node agent will know this is a shared profile because its EPP value will be equal to power. The power node agent will know that a shared workload is to be designated as a shared workload because the all cores flag will be set to true. The name of a shared workload must also begin with a shared hyphen. It will be rejected otherwise. The shared workload is the only workload that must be manually created by the user. The reserved CPUs on the node must also be specified, as these are not considered for frequency tuning by the controller, since they are always being used by Kubernetes processes. It is important that the value of reserved CPUs in the workload directly corresponds to the value of reserved CPUs in the user's kubelet config to keep them consistent. The user determines the node for this power workload using the power node selector to match the labels on the node. And finally, the user specifies the requested power profile to use. In this case, we'll be requesting the shared profile. So if we apply the shared workload, we'll see the workload being created down here. We'll show again the core's frequencies, which will now have the reduced values of the shared profile. If I just quickly show you the shared profiles frequency values here, we see here that the shared profile has the max frequency of 1100 and the minimum frequency of 900. And you can see here that the shared pool is affecting cores 1 through 95 and core 0 is unaffected. So if I show the frequency values of CPU1, the max frequency is now down at 1100 and the minimum frequency is now down at 900. And now we have a pod that will request two cores to be configured with the performance power profile. For a pod to utilize a performance power profile, it must be in the guaranteed quality of service class and also request the profile as an extended resource in the form of power.intel.com/performance. And I'll show you that here just for reference. You can see here power.intel.com/performance. The number of profiles requested must also match the number of cores requested to allow the kubelet to keep track of how many are in use. So if we deploy that pod now, and we'll just make sure this pod is running. There we go. So once that is deployed, the pod's cores will be retrieved by the Power Node agent and placed into the Power workload, after which the core's frequencies will be updated. And we can see that here. If we check the maximum frequency values again, we have it at 3000 and the minimum value is 2800. And that has been the demo of how the Power Manager works. Thank you very much.